We're going to be creating ransomware using C# in this video. Now, first of all, I have to lead with this. Absolutely do not use this for malicious purposes without consent on, systems that you don't own or have authorization to run this kind of thing on. Now, what you're going to notice about ransomware is, even though it sounds super crazy, right, it can actually be very simple as well. Now, there's a lot of stuff we're not going to be taking into account in this video, right? We're not going to be taking into account proper OPSEC and trying to do this in a sneaky way that is very difficult for us, to trace back to us and all this kind of stuff. We're not going to worry about any of the super, real world stuff on this yet. This is more of a proof of concept, but definitely something that we can expand upon in the future, depending on how sophisticated we want to get with this program here. So let's have some template, a little template here that I can insert into and start writing some C#. Now, the very first thing we're going to want to do to demo this is we're going to keep this at a very small scale for now. So I went ahead and created a folder here in the public directory called My Files. And essentially what this is going to do is exactly what ransomware does. Just loop through all the files and encrypt them. So encryption is really big, and that is something you got to understand is how do you encrypt files? So there's tons of ways you can do this in pretty much every programming language. I'm going to use what is known as symmetric key encryption. So using the same key to encrypt as to decrypt. So we'll be diving into that. But first, let's just get this started on one singular file. That's the most simple way to approach this. So I'm going to go ahead and create a new text document, and I'm going to call this simply file.txt. And I'll populate it with some lorem ipsum, just some placeholder data, essentially. So there we go. We have some data in this file. And all right, let's just get right into it. So the very first thing that we need to do is let's first declare this directory as a variable. That way we know what we're referencing when it comes to this stuff. So if I do string dir, I'll call it dir, and the @ symbol is normally how you reference a path. And we'll say the path is users public my files. And once we've done that, let's tell it the actual file. Let's set that as a separate variable, and we'll call it plain text file, just to be nice and descriptive here. And that's going to be this working directory plus the name file.txt in our case. So this will be the full path to our file. And by the way, this is just how I dreamed up the solution. There's different ways you can write this, and I'm making no claim as to be the proper, most, developer approved way to do it. There's probably a better way to do what I'm doing, but this is more of a rough, kind of quick and dirty proof of concept. We can always refine it over time. That's the beauty of code, right? You always start with your beta, your version 1, your early alpha or whatever, right? And basically always the code you start with is never as good as it will end up ultimately being. So keep that in mind. This is a very rough piece of ransomware that we're just throwing together for now. Not everything will be the most optimal way for all you super coders out there. So let's create another variable that will be our encrypted file, because we're going to encrypt and we're going to have one to encrypt and one to decrypt. So we'll call this quite simply encrypted file. And that will be, we'll have it write that to a separate file called encrypted file in the same directory. So that's why I have dir. So it's going to create this encrypted file. But right now I'm just declaring the variables. And then when we decrypt it, we'll just set that to a separate file. That way we can look at all three files and make sure that everything is working properly. And this is how I like to build out code. This is how I like to go about it, because you don't want to try to do everything at once. You want to do it in increments. That way you can confirm that what you put together is working before you move forward. Because if you write the whole program and hit run, there's so many potential areas of error, right? So many multiple errors could be introduced, and it'd be a lot harder to debug than if you just build it piece by piece and make sure that each individual piece is working. Let's just create all 3 of these. And the library that I chose to work with is called Sharp AES Crypt. Like I said, there's many different ones you could use. Now, if you're not too familiar with Visual Studio, what you do is where it says the name of my program here, which is called test. If I just right click that, I can go down to where it says manage NuGet packages or nuggets or however you pronounce it. And that will bring this up here. As you see, I searched for it or already installed it. This one I put around with a couple others too. But this one here, sharp AES crypt.dll. Now, if you don't have it, go to browse and you can search for AES crypt. And you should see it here. Not the exe, that one's deprecated, but the DLL. You just click on that, and then you click, it would say install somewhere down here if I didn't already have it. And just clicking that would install it automatically, and then it would show up here. So that's basically what we need to do. So to use that, we need to import. So let's go ahead and import sharp AES crypt. So now that we have that, we can actually use this library. And the first thing we're going to do is we are going to encrypt the files. So we can do that by calling sharp AES crypt, the encrypt function, and then we can pass it a key. So if we just have the key quite simply as password for right now, not the best ransomware, I know, but we could have this as anything. But let's just start simple here. We could always make it a more complex key as we go. So we're going to take in the plain text file, and we're going to save it as the encrypted file. Let's just go ahead and run what we have. So if I just run this, we'll let it build and do its thing first. And the first time you build it and everything, it might take a minute. And we're not really looking to see anything on the console per se, but just to make sure it happens, it goes through with no errors. Now we can check in here and we see that this encrypted file was created. And that's because we called it encrypted file.txt right here. So we have our original file, which is the plain text here that we saw earlier. And now we have the encrypted file, which should be the ciphertext. Yeah, the obfuscated version. So this is an encrypted file. We have now encrypted this file. So obviously we can't really access it unless we have the key to decrypt this file. So that is the essence of ransomware. Basically, it's malware that goes through and encrypts all your files using a key that only the attacker knows, and so that you lose access to all your files. And the only way you can get it back is to pay the attacker money, and he will use his or her encryption key to decrypt your data for you, and then you'll get everything back in the original format. So let's go ahead and try that, right? Let's go ahead and try to decrypt this. So now that we ran encrypt, I can comment this out. And let's just write a decrypt function. Well, it's very similar. It's pretty much the inverse to write the decrypt function. We can, instead of encrypt, we write decrypt, and then we pass in the key, which was password. So we would have to know this key. We'd have to have the key, right? And then we're going to do it in the opposite manner. So encrypted, and instead of writing it to plain text, because we already have a plain text file, we'll write it to a new file called, up here, decrypted file.txt. And so what we'd expect to see is a new file called decrypted file.txt, which should contain the original plain text if it ran properly. No errors, so looks hopeful. Here's our decrypted file. Open that up, and we see the original file. Next thing that we can do really quick is we could just remove this functionality here, how it creates a separate file. And we might want to encrypt the original file, right? Now, to do that, there is a little bit more at play here, right? Because I cannot simply do it like this. Let me show you. This is probably how you would think to do that. If you wanted to encrypt the original file, you might think, oh, okay, well, you just remove the decrypted part and you take in the plain text file and you just save it as plain text file and overwrite it, right? Well, you actually are not allowed to do this. And if I try to run this, you'll see why. It should fail on this line here. And it says, cannot access the file because it is being used by another process. And what it means is that we're running encrypt on this file, so it's open in that process, so we can't also write that to the same file. So what we instead need to do is we need to continue to write it to a different file. So we can write it to encrypted file. Okay. So let's continue that, and let me go ahead and exit out of this. And instead what we're going to need to do, or one such solution that I chose to go with, is to go ahead and write it to the encrypted file just as we did before. But then after that, have some file operations, right? Some file IO. So if I say file.delete, we can delete this plain text file after we're done. And instead, just delete it and then move this file over there. So then a file.move on encrypted file to plain text file. So what that's going to do is move encrypted file.text into file.text, thus replacing the original. And another thing I'd like to mention actually before I run that is if you didn't do the delete, if you just tried to do a move straight up without deleting this first, it will also fail. And I'll show you what that looks like just really quick here. So it cannot create a file, and it kind of cuts off the error message here, but what it's saying is that it can't create the file because it already exists. So that's why we delete it first, so that it can then recreate it. And we see that the file is now encrypted. But of course, there's a lot more that we'd want to do to get this malware ready, to get this ransomware going. So let's do exactly that. Let's expand on this. Let's add to this, right? Because what if we had multiple files? What if we had, I don't know, like 6 files in this directory? Let me just go ahead and create that. I'm going to use PowerShell to speed it along. I could write a one-liner, but what I'm going to do is copy this to file 1.text. And let me just move this up here. So I'll just do it like this. File 2, 3, 4. I'll just full screen that so that doesn't get cut off anymore. And yeah, let's just say we have like 6 different files here, and they all, they're all like this pretty much. And I'll just have like some filler data, some lorem ipsum in there. And now we have multiple files. So how would we go about writing some ransomware that could encrypt all of these? So after we set our working directory, what I'm going to go ahead and do is I'm going to create a list data type that holds some string values in it. I'm going to call it files. And I'm going to initialize that here like this. And once I've done that, I am just going to create a directory info data type and initialize that. I'm going to call it, I'm going to set it to the variable D and initialize that as well. What I'm going to do is then build out a list of files. And I'm going to just keep appending to this list to build it out. So if we do a for each loop, we could say for each, and then we'll declare a variable called file. So var file in the.getFiles is a built-in method here that's going to get all the files in that directory, right? And the reason that I pass dir into directory info is that we want to use this path here, C users public my file. So anything in that directory, it's going to be contained in this variable here. And now we can just call the getFiles method on that variable in order to get the files. So leveraging some built-in to the .NET framework kind of functionality here. So .text, so anything that ends in .text, because these are .text files, If we wanted to account for other files, we could absolutely do that as well. Like I said, we're just going to keep things simple right now. And now we can have the logic that it's going to do for each of these files. So for each file, right, what do we want to do? We want to build out this list, so we need to append. And that's the nice thing about Visual Studio. You see here, it is able to predict what I want to do with it. And it's almost right. It's not quite correct. So I want to add file dot to string. And maybe dot full name would have worked, actually. This is how I opted to do it. But yeah, you probably could have done dot full name as well. Maybe something to test out later. But let's just go ahead and do this. It's going to build out the array, or the list, I should say. And that's not all, right? What else do we want to do? We want to do something with this list once it's built out, right? We want to encrypt and decrypt. Those are the two main things we want to do. So let's go ahead and write those functions. And we've already kind of written them, but now we have to apply it to the list instead of working with a single file. So encrypt all files, and we could say decrypt all files. These are the two things we want to do. So later on, we'll add these to their separate methods, but let's just write it all out first and get it working. Then we can later on, and maybe in another video, clean it up. So for the encryption, we're going to loop through this again. So for string file and files, now what are we going to do for each one, right? We want to go ahead and we basically want to do what we did earlier on. I'm going to take this part. We'll have this, and then we'll have the actual encrypt line here. And we're also going to have the delete and move. So basically everything we did earlier, we're just doing that for each file in our list. So for every file in that directory, we're going to do this. And then once we've done that, we can do the same thing, but in the inverse for the decrypt function to speed things along. I'm just going to write this here. And oh yeah, I will need to add the plain text, not the plain text file, but we're going to have to make a slight change here. So instead of working with plain text file, there's no plain text file variable. It's just file. Now I got to change the encrypt to decrypt. And here, remember, we're not working with encrypted file. We're working with just the regular file, just file, and get rid of the typo. And yeah, now everything should be good to go. So this is going to encrypt and then decrypt. So let's just go ahead here and, you know what, I'll just recreate this file here. So yeah, if I just get rid of that. So now let's just go ahead and have this run. So let's comment out this part for right now and just do the encryption. So we run this. So this should loop through and encrypt all the files if it works properly and we didn't have any major typos in here. So it's building and running it. And no errors. That's a good sign. Now let's take a look at the folder here. We have these files. Let's just click through them. Encrypted. And yeah, they all seem to be encrypted. Awesome. So we have just went through and encrypted all these files. So now let's just go ahead and do the inverse. Let's uncomment this code here and comment out the encrypted part. And of course, later we can have some logic to do this automated, but yeah, let's just go ahead and try and now decrypt all the files and no errors. Great. Let's just take a look at a few of them. And there we go. We have them in plain text, as you can see here. So perfect. Looks like they all decrypted as well. So yeah, we've basically written the outline to our ransomware, and we can just keep adding on. One thing I would like to add on is, what if we had some folders? What if they weren't all just files in this directory and we wanted to do this recursively? How would we go about determining if it's a file or a directory, and if it's a directory, going into that directory and encrypting all the files within that, right? That would be an interesting thing to do. And also counting for different file types and things like that, which, to be honest, that'd be very simple. We just change this little area of the code right here to do that. But yeah, if all this sounds interesting to you, definitely stay tuned to the playlist for more. Catch up on the playlist as well. I'll have that on the screen for you right now if you're not up to date, and I'll see you guys right over in those videos. Thanks for watching. And I will say as well, while you're learning this stuff, eventually you will become ready to get a job, and maybe you are actually writing malware and stuff like that as a red teamer and having your own custom code that you guys run in your environment to excel at your red team engagements and provide massive value for your company. Well, along that journey, you're definitely going to come to the point where you're ready for your first job, or maybe that higher paying job, and you're going to want to arm yourself with the top 10 pen testing interview questions that you need to know to land that sweet job in the first place. So go ahead and check out the description below, and you'll get that absolutely for free.